For years, if you heard quantum computing, you'd probably picture, I don't know, science fiction, maybe some university lab.
Right, something that felt a decade away from being, well, real.
Today, that changes. We are witnessing, I think, the moment that theoretical quantum research officially crosses over into practical enterprise utility.
That is precisely the shift, and that's why we're doing a deep dive into the launch of Quantinuum's Helios quantum computer.
Yeah.
Because this isn't just another system launch, it's a strategic move that really redefines the whole quantum race.
So our mission today is to figure out why this specific piece of hardware is such a strategic shift for business. Why does it matter right now, and why isn't it just another tech update you can, safely ignore?
The quick answer is one word: accuracy. Helios is being positioned as the most accurate commercial quantum system out there.
Yeah.
And the proof this isn't just marketing hype is who's using it. We're talking about massive players like SoftBank and JP Morgan Chase already getting early access. When you see institutional capital of that size committing, you know the technology has to be serious.
And that immediately hits on the biggest blocker in the history of quantum computing, right? The noise.
Exactly.
If you're listening to this, you almost certainly know the challenge. These calculations rely on these incredibly fragile, entangled states and just one tiny error.
Just one qubit flipping when it shouldn't.
And the whole circuit breaks, hours of compute time just gone, useless.
A single bad calculation just ruins everything. And up until now, that noise has limited the depth of the circuits you could run.
You have to keep things simple.
Super simple, really shallow calculations just to have any hope the result wasn't total garbage.
So the breakthrough with Helios is its accuracy. This lets you run deeper, more complex circuits reliably. I mean, if we want useful commercial-grade quantum, that reliability it's everything.
It's the foundation.
So how do they do it? What's the leap here?
Okay, so that gets us to the core technical decision they made, which is the architecture. Helios is built on what's called trapped ion technology.
Right.
So instead of using those super-cooled, superconducting circuits, which are really prone to noise, Quantinuum uses electromagnetically suspended ytterbium ions. These ions, they are the qubits.
We hear about superconducting qubits all the time from, IBM, Google. So why are trapped ions suddenly giving them this massive edge in accuracy? What's the physics behind that?
It all comes down to control and isolation. Trapped ions give you two huge advantages. First, they have these inherently high coherence times.
Meaning the qubits just stay in their quantum state for long.
Much longer. And second, and this is crucial for complex algorithms, they deliver significantly lower gate error rates.
Okay, hold on. Let's pause on that gate error rates. Why is the error rate on the operation, the gate, more important than just the raw number of qubits we always hear about?
Because a quantum computer is only as powerful as its weakest link. Look, if you have 100 qubits, but your error rate is high, you can only run a circuit maybe, 5 or 10 gates deep before the noise just completely overwhelms the signal.
Right.
But if you have fewer qubits, say 30, but you can run circuits 50 or 100 gates deep with high confidence, well, that machine is infinitely more useful for solving real business problems.
So this is the shift. We're moving from focusing on the quantity of qubits to the quality of the interactions between them.
Absolutely. The metric Helios is hitting is a record low 2-qubit gate error rate. And those 2-qubit gates are the hardest part.
Because you're trying to connect two separate quantum states without messing them up.
Exactly. And reducing that error is the sign that the system is ready for real industrial work.
The architecture also gives them this scalable all-to-all connectivity. What does that actually mean for a business user?
It means less complexity. In a lot of other systems, if you want qubit A to talk to qubit F, you might have to route that information through B, C, D, and E.
And you're introducing a little bit of error at every single step.
A little bit of error every time. With trapped ions, any qubit can talk to any other qubit directly. This just slashes the circuit overhead, which means those deep, complex financial simulations suddenly become feasible.
Okay, so this boils down to the key takeaway. This level of accuracy means companies can finally move beyond those academic experiments.
The toy examples.
Right, and start testing real industrial use cases, the kind that actually move billions of dollars.
And it's designed to be future-proof. Helios is modular. These units are designed to eventually be networked together into much larger, fault-tolerant clusters. Think of this as the first high-quality engine block for a future quantum supercomputer.
Which leads us perfectly to the immediate validation. who is actually using this. When you see JP Morgan Chase and SoftBank lining up, I mean, that's a massive signal.
It's the ultimate market proof. Their involvement tells you that these organizations believe the tech is mature enough to solve industrial-grade problems today.
Let's start with JP Morgan. They're probably the biggest institutional investor in quantum in the world. They don't just have a lab, they have a whole strategy. What are they using Helios for?
Their focus is on these high-dimensional, high-risk financial problems. They're using quantum Monte Carlo simulations to calculate risk exposure.
Across trillions of dollars in assets.
Trillion. So for anyone who's not deep in finance, Monte Carlo simulations are how banks model random events like market shifts.
Right.
On a classical computer, this is incredibly time-consuming. Quantum Monte Carlo could potentially speed this up exponentially, giving them a real alpha advantage, a proprietary edge in risk modeling.
And they're also looking at things like quantum linear algebra, fraud detection, stress testing their cryptography. They're basically throwing their biggest computational bottlenecks at this machine.
That's it. This is one of the first true enterprise-scale financial workloads running on a commercial quantum machine. This isn't a small optimization. This is about managing hundreds of billions in risk.
And then you have SoftBank. They're less about banking and more about, huge global capital allocation.
Right.
What's their angle?
SoftBank is all about complex optimization. They're using Helios for portfolio optimization across their massive holdings, trying to figure out how to best weigh all these correlated assets.
So because they run the Vision Fund, they're essentially using quantum computing to price and hedge these huge volatile tech bets.
Correct. And they're also applying it to their telecom interests, looking at network optimization problems. These are classic challenges that choke even the biggest classical supercomputers.
The source material had a really great analogy for this.
Yeah, it's like moving from a prototype self-driving car to a car that reliably stays in its lane.
I love that.
It's the difference between a technology that needs constant babysitting and one you can now trust to run a mission-critical process. The reliability is it's baked in.
It changes the whole conversation from, if we build this, will it even work?
To, okay, it works. How do we build this into our 2026 strategy?
Which is the perfect segue, the strategic implications.
Right. And the competitive landscape.
The launch of Helios has just completely shifted the dynamics of the global quantum race. The battle is now officially about error correction, not just qubit count.
And we should acknowledge the field is deep. You have IBM, Google, IonQ. They all have massive resources. But Quantinuum is making a very direct claim. They're positioning themselves as, quote, the first vendor crossing into reliable quantum computation territory.
That is a direct shot at the entire industry.
Yeah.
So what does having JPM and SoftBank on board do to the rest of the corporate world?
It creates instant FOMO, fear of missing out.
Of course.
When these huge players bake quantum into their roadmaps for 2026, 2030, it forces every other major corporation to develop their own quantum strategy immediately.
This feels so familiar. It sounds exactly like the early days of cloud adoption in the 2010s.
The parallel is explicit in the sources.
Right, where suddenly every CTO realized they needed a cloud strategy just to stay in the game.
That's it. First the enthusiasts adopt, then the big risk-averse companies test it, and then suddenly, cloud, or in this case, quantum becomes a necessary part of your compute strategy.
So let's break down the impact on a few key sectors. Financial services seems to be the first big winner.
For sure. Early adopters are going to get real, tangible alpha advantages in risk and derivatives. But beyond that, they're also using it to stress test their own systems against future quantum decryption.
The long-term cryptographic risk.
A massive concern they can start tackling today.
Okay, what about pharma and material science? Fields where accuracy is everything.
Here, accuracy is totally non-negotiable. One tiny error in a molecular simulation means a failed drug trial.
Or a useless new battery material.
Right. Helios allows for much more reliable simulations of complex molecules. That means faster drug discovery, better battery materials, new catalysts. We should expect big pharma partnerships to follow JPM very, very quickly.
Now let's talk about the big one for our audience, AI and quantum. The hybrid workloads. Why is the accuracy of Helios so important for machine learning?
Well, classical AI relies heavily on these complex data structures called tensors. They're just high-dimensional arrays of data. And quantum computers can, in theory, optimize how you calculate with these large tensors far more efficiently than a classical chip.
So when we hear quantum-enhanced tensor optimization, we're talking about using a quantum computer to speed up the core math inside a massive AI model.
Precisely. Helios is perfect for these hybrid classical quantum ML loops, for instance, in optimizing parameter estimation for a large language model, which is basically teaching it what to value quantum could radically speed things up,
Making those LLMs cheaper and faster to develop.
which connects quantum directly to the huge data center strategy conversations that are happening right now.
And all of this just reinforces the view that quantum computing is becoming critical infrastructure. It's fueling this global compute race.
Absolutely. This isn't purely academic anymore. It strengthens the competition between, say, the US and China, and it blurs the line between corporate and sovereign compute. Quantum is now a strategic asset, just like chip fabrication.
Before we wrap up, we have to touch on the technical details that made this possible, and, just as important, the remaining risks.
Right, the reality check.
So how did they physically engineer a cleaner machine?
They cite a few key advances. First is next-gen trapped ion control, which means much higher laser stability.
Okay.
Think of the lasers as the hands manipulating the qubits. If the laser jitters, the qubit gets messed up. Better stability means cleaner operations.
Tighter control means less noise. What about ion transport?
Improved ion transport means they can move qubits around the chip more gently, more quickly, without adding noise, which is key for that all-to-all connectivity we talked about.
Yeah.
They also have new error suppression software that works with the hardware to filter out flaws.
So it's an engineering challenge, getting faster without getting messier.
That's it in a nutshell.
But let's be balanced. What are the risks a CTO still has to deal with?
The constraints are still very real. First, cost. Cloud access to these systems is expensive. That limits who can really experiment at scale. Second, while the quality is high, the absolute scalability challenge is still there. We are not yet operating systems with thousands of physical qubits.
And the high cost and scaling challenges mean long-term reliability in a real commercial setting is still being proven out.
That's right. But maybe the biggest hurdle for an enterprise is algorithmic. Quantum computing is not a drop-in replacement for a server.
You can't just port your old code.
No. To use Helios effectively, you have to completely redesign your algorithms. It's a fundamental shift.
That sounds like a massive investment in people. You need physicists working with your application engineers.
Exactly. You're investing in a whole new paradigm. And that complexity means only the largest firms like JPM and SoftBank can really make this jump today. But the direction of travel is clear.
Which brings us to the summary. Helios is a milestone. It marks the point where quantum crosses from interesting demos to reliable commercial-grade experiments.
The bottom line is, this launch accelerates the timeline for financial adoption, it ratchets up the quantum arms race, and it supercharges hybrid AI quantum research. Quantum is now a strategic technology you have to plan for.
And this convergence of technologies, the error suppression, the trapped ion control, it pushes the entire industry closer to the ultimate goal. Logical qubit formation.
The logical qubit, the stable, error-corrected foundation for all future truly fault-tolerant computers. This level of accuracy, it forces a dramatic rethinking of the timeline.
Which raises a really important question for you to think about. If the fundamental physical building blocks of quantum are already this much cleaner today, how much sooner does the arrival of true, large-scale, fault-tolerant quantum computing get accelerated? That is the strategic timeline that every CEO and national security advisor is calculating right now.